Okay, welcome back, everyone. In part two of our lecture, we're going to actually talk a little bit about models and break them down a little bit more. So we're going to talk about the different model fields: integer, decimal, date time, date, the Boolean, character field, text field, and the email field. There's a plethora of other fields, but we'll talk about that here shortly. We'll then talk about how to update our data, the process of updating our data, such as generating fixtures, expanding on the Pokemon model. We will then actually create some model methods. And finally, we'll talk about an easier way to interact with our models than doing it through the Python shell. So starting off with the first portion is taking a look at what actually comes within models. So let me go ahead and share this here. Yep. So I'm gonna grab this and share it inside the Buffalo Questions channel. I also jumped into a couple of breakout rooms. In case you haven't taken a look at the Buffalo Questions channel, I shared a guide for getting everything up and running. So hopefully that's helpful. But here inside of the link that I just shared in the Django documentation, you can take a look at all of the different field types that are available. There's these field options, which we'll see here shortly. That's information that we can pass into these fields. These are attributes for the classes of field types. But in the field types, we can take a look at pretty much everything that's being provided for us. So here we have an auto field, a big auto field. This is utilized for primary keys. We have integer fields, binary fields. There's the Boolean field, which could always be set to true or false, and you could provide a default as well. Composite primary key. That one's new. I've never utilized that one before, so that's interesting. And then a character field. So a character field is essentially just a varchar. You could specify things like max length, and here it tells me, hey, let me go ahead and zoom in a little bit. Here you go. So here it tells me, hey, there's such a thing as max length, which can be enforced. So just like any database, we have up to 255 characters inside of a character field, but we can set it to something else, right? So let's say I'm taking a middle initial. Well, I know that that should only be one or none. That way I could just save up some memory on my database side. There's date time field, and notice that it gives me a couple of other options that are available there. So here it tells me, hey, auto now, which is false. So this auto now portion kind of tells me like, hey, if I turn this into true, then by default, it's always going to be the moment that the instance is created. So let's see. Now every time the object is saved. So useful for last modified. Okay, perfect. So whenever the object is saved, so that's not necessarily the same thing as when the object is created. So that's important for me to know. It also gives me the source link that I could open up, and it takes me directly to the datetime field as to how this class is being written. So notice that it's still just a class, just like we saw before. It's utilizing composition. Here's all the different values for strings that it's being created. These are class level attributes. And here is the init method. So these are the different attributes that we can pass onto it. It also shows me some of the different methods that work there. So if I truly want to understand how each independent work field or each independent field works, I can dive into the code and take a look at everything that's going on in the background. Now, date time field is a good one to keep an eye out. If you're creating users and you want to keep track of, hey, when was the last time they were logged in, or you're managing tokens, or let's say you capture a Pokemon, a date time field would be utilized to make sure, hey, this is when information is coming in at. And notice that it's even telling you, hey, if you want to utilize a default, make sure that you're utilizing timezone.now from Django.utils, not from Python timezone, but from the utilities that comes from Django. So that's another thing to make sure that you're looking at. Whenever you're utilizing these fields, especially if you're building an application that you really want to deploy, a lot of the information that we used to write within our excuse me, everyone, a lot of the information that we used to write between our SQL files, such as constraints and relationships, they're all going to be reinforced by Django now. So we don't have to worry about writing them inside of our SQL or writing them straight into our SQL file. We just want to make sure we leverage Django's ORM to write everything in a Pythonic fashion and make sure that it gets implemented inside the database. All right, so datetime field, same thing. It's going to give me some sort of breakdown. It still has the option for me to take a look at the source. And here's a warning. So always use datetime field with a datetime.datetime instance. All right, if you have a datetime date instance, it's recommended to convert it to a datetime first. If you don't, datetime field will use a midnight in the default time zone for the time component. This is true for both storage and comparison to compare the date portion of a datetime field with a datetime.date. All right, so important thing to annotate there. Our decimal field can become a little bit tricky when you're trying to describe it. Something like this, which is 999.99, is actually 5 separate digits. And then you would describe that you need 2 decimal places, right? So in total, we're going to intake 5 digits, but we'll move the decimal 2 places from the right to the left. All right. There's a email field, which is super nice because that way I don't have to worry about writing some sort of regex, making sure that the email is valid. This is already providing it for me. Um, there's a file field, which we're not going to talk about files here in Code Platoon or images, but know that there is a way for you to upload into different media, different types of media inside of Django. Um, And there's a plethora of other fields that we can work with. So with that said, again, make sure that you're reading the Django documentation when you apply a field. More than likely, if there's some unique instance that you need to keep track of, such as a file path, an image, there is a way for Django to be able to store that information. All right. So now that we've viewed a little bit about all the other different types of fields that are available, let's go into updating our model and the process of updating our model. Well, as of now, we this process would be kind of like refactoring, right? So we generated a model, so created the first instance of a model. We also created an entry to the model. And now we want to improve the model. So in other case, alter model for improvement. But when we alter this model for improvement, we probably want a way to maintain a consistency within this data. So how do we do that? Before I alter the model for improvement, I want to create a backup file. Now, this backup file is named a fixture. So let's go through that process. Currently, we have a model inside of my Pokemon app. If I come over, I can see the model, and I know I have an entry inside said model. Well, if I enter the shell, so I can go Python manage py shell, and inside of the shell, let me make sure that I can actually grab the Pokemon class here. Okay, so there's the Pokemon. So let's print the name of the very first entry. And I'm actually querying the database here. We'll go over different methods for querying the database here shortly. For now, don't worry about it, right? So I can print the very first entry to see the name. I can see that's Pikachu. So all of that has been great. My data has been maintained, but I'm going to be improving this model. Now, I don't want Pikachu or anything else within my database to be hindered by the change in this data. So I need to back it up somehow. I need to make sure that it stays clear. Well, we're going to do that by actually generating a JSON fixture. we create a JSON fixture by simply saying Python manage.py dump data. So that dump data command then takes in a path to the model that I want to dump data from. So I'll say Pokemon app dot Pokemon. I want to dump the data indented by 2, and then the location that I want to dump it. So I want to dump it into my Pokemon app under fixtures. And I'll probably want to create this directory first. And I'll say Pokemon.json. Let's do Pokemon data.json. All right, so this should raise an error because it's going to tell me, hey, this directory doesn't exist. That makes sense. Let me make my directory for Pokemon app fixtures and then execute that command one more time. Okay, so now the command was successful. And if I open up fixtures, you'll see that there is a JSON file that's been included. That JSON file holds a list of objects where each object represents an entry into that specific data table. So here it tells me, hey, the model that we're talking about here is going to be the Pokemon inside a Pokemon app. The primary key that was assigned to it was of 1, and the fields with their values are as follows, where we have a name Pikachu and the level of 22. Right, so we were able to successfully grab our data that's inside of our SQL file, or excuse me, that's inside of PostgreSQL, and store it in a JSON format. So now that I've been able to create my fixtures, I can actually improve my model. Before I continue moving forward, does anyone have any questions regarding fixtures? Go ahead, Tom.
So anytime that we're going to modify a model or create a new field, I guess I should say, it if we want to retain the data uh, of this model, we have to dump it.
So that's a good question. And I want to clarify that data isn't going to be removed. This is more of a backup. So let's say I make some changes to my database, and then I try to make sure that my data still persists. But then I start seeing a bunch of errors coming up saying, hey, making these changes would break X, Y, and Z, or these changes aren't feasible because you need some sort of default value for all previous entries, and we don't want to do that. Well, now I could just simply back up my database model and still have an existing data file, right? And I could also save it as to each stage that my data is currently at. So I could say, hey, this is my initial stage of my Pokemon app. And when I make changes, I could make another fixture saying, this is the fixture representing my data as of this date at this time, right? So it's just a living record of what your data looks like within your database that you can always go back to. It's just another form of version control, for lack of better words. It's ensuring we can always have a document of truth that we can always go back to. Does that answer your question, Tom?
Yeah, I think so. What was
Okay.
the command that you used to
Uh,
dump it?
yeah, let me go ahead and share that inside of the bubble of questions. And go ahead, Alex.
Yeah, just to sort of finish off where you guys or start where you guys finished off. Why don't we just this sounds like a you could just do this with Git, no?
So that's a great question. Let's say I just do this with Git, right? In order to just do this with Git, rather than having a file that I can easily execute and run back to, I would have to quite literally interact with Git and revert into my previous commit, et cetera, right? When it comes to data, you want to be as careful as possible. So yes, short answer, big picture, we could utilize Git, but as I'm sure as everyone here has experience, it's not that easy to get Git, right? Git can become a very complicated tool, especially when you're trying to merge different branches, You're working with multiple commits. Most of them aren't going to be your commits. They might be from other developers and they might have made some changes to the table. So it's not the preferred method for handling these changes would be with Git. Does that answer your question, Alex?
It
Okay, I see
does.
head
Oh,
nods.
and the fixtures. Um, can you go back to the I guess page before or the file you were working on before fixtures? Were you on models?
I wasn't working on any files. I was just taking a look at models, but I haven't changed anything to my application yet.
Oh, okay. So fixtures populated because we created in the CLI.
That's correct.
Okay. Okay, got it.
All right. Any other questions? All right, great. Well, now that I have a fixture that reflects my Pokemon data, I can finally go into improving my model. So, for example, my models.char field, I probably won't need 255, which is the default value. At most, I may need something like 50 characters. And for my level, well, I know I can set something like a default value. And let's say the majority of Pokemon that you find, well, they wouldn't be anything less than a level 1, right? So we can add a default value there to make sure that our integer field is holding that information. Now, additionally, we can also add a couple of other fields here. Let's say we wanted to, I apologize, everyone, I'm trying to find, there you go. Let's say we wanted to add a couple of things like, hey, I want to also see when I encountered this Pokemon. And that's for my Pokédex. And it looks like my handy dandy Copilot is trying to kick in. Let me put it back to sleep. And here I can say, hey, well, I want to utilize something like models that date field, right? I could even say I want to capture a Pokemon. Say models dot date time field, which would allow me to capture a Pokemon. I could add a description to a Pokemon. And in here, I may need something a lot more than just 255 characters. Maybe I want to describe the different types of food this Pokemon may like, what kind of berries work best with it. Maybe it has some evolution restrictions that I should take into consideration. So here I can say, hey, I want a text field, where a text field has no character limitation. And then finally, I could have a captured field, which is just a models dot boolean that I can default to false. All right. Well, let's see what other kind of default values we can provide here. Well, for example, my datetime field, as we read in the Django documentation, I can say from Django dot utils. And let me actually fix my VS Code because this squigglies are driving me crazy. This doesn't really change anything regarding our curriculum that we're covering, so please disregard what I'm currently doing here. All right. So from Django utils dot datetime, I think that's where it comes from. Let me see here. There you go. Time zone. All right, so from Django's utils, import time zone. And now in my datetime field, I can pass in something like, hey, date or default is equal to time zone dot now. And something like date field, well, let's take a look at what the Django documentation said regarding the date field. I'm gonna come back up all the way up here to this breakdown, go over to date field. All right, so date field has an auto. Let's see if it has anything regarding a default parameter that I can provide. Okay, warning, datetime field, datetime.date. Instance, if you have a datetime.datetime, it's recommended to convert it to datetime.date first. Okay, awesome. So let's see. Always use date field with the datetime.date. Yeah, I wonder if there's Django.date. Oh, that's not it. Hmm. I'm unable to find it right now. Unfortunately, I wonder if it's within time zone. There you go. So it is within time zone. So I could just set a default, which is time zone dot datetime dot date. And that will set my default as well for my time zone. All right, and that comes straight from the Django documentation. Now I can also add a default for description here, but instead, for now, yeah, why not? Let's do a default. And let's just say this Pokemon is unknown, and we will update its information when possible. All right, so there's quite a bit of changes that have been made. I provided default values to everything. Um, I have my integer field now, my char field, which has its max level of 50. Well, now I can actually update this information. But how does this update happen? How do I alter and create new fields? Well, just like before, I want to execute Python manage.py, make migrations. And it seems like it's saying there's no changes detected, which is interesting. Let me run ls to make sure I'm in the correct directory. pwd. Okay, so it seems like I was in part one, which makes sense. Okay, so now Python manage py. Actually, let me run ls here. Let's run Python manage py, make migrations. Okay, now I'm getting a little bit of an error. Let's see what's going on here. All right, so it's saying, hey, cannot serialize method date of datetime.datetime objects. There are some values Django cannot serialize into migration files, and here it tells me this is why. Okay, awesome. So if that is the case, instead of trying to provide any sort of information there, what I'm simply going to do is I'm going to manually provide one. I'll say, hey, we're going to do 2008-01-01. And I know that for future implementation, whenever I write a new file, I would want to utilize timezone.datetime.date and then pass in the value. Okay, now I can make migrations. We can see that the migrations was created. Here we have a couple of added fields and some alter fields. So we altered the field of name, altered the field of level, and we added a couple of new fields. Now, before I actually migrate this into the database, I want to talk a little bit about what migration files look like now. If we take a look at our migration files, we had 001 initial, and now we have the 002. Well, notice how 002 has a dependency now. meaning that anybody who installs this Django application, they would not be able to execute this file unless they had access to Pokemon app 001 initial. Each migration is dependent on the previous migration file. Now, this gives us the ability to kind of delete and alter migration files. It's a little bit out of scope, so we're not going to cover it here in Code Platoon, but know that that is an option to just directly interact or write your own migration files. All right. So now it says, hey, we have a dependency on this initial file. So the initial file is read. After the initial file is read, then it goes through the process of reading all the operations here. Here we can see a couple of alter fields, and then we see all of the different add fields within migrations. Okay, in SQL, none of this has been implemented just yet. SQL still looks as such. Well, now I can say Python manage py migrate. That will apply my migrations file of 002. And if I come back over to SQL, now SQL has the ID of name, or excuse me, the ID of 1, name of Pikachu, level of 22. The captured Pokemon date is now today. Captured is defaulted to false. The date encountered is as such. And finally, we have our description text, which our description text falls into this Pokemon is unknown, and we will update its information when possible. All right. Okay, so the process again, we created a fixture. We then made some changes to the database. And now we can go through the process of generating a fixture that holds all of the changes. So now I can say Python manage py dump data. Again, I will reference the Pokemon app.pokemon, specify the indent of 2, and I want to dump it into the Pokemon app fixtures at Pokemon data. And I'm going to name it 002.json. So now I have a living record where in the first one, my initial migration, this is what my data structure looked like. And now after applying 002, this is what my Pikachu looked like. Okay, well, now how is this useful? What else is useful about these fixture files? Because as of now, sure, yeah, they're maintaining my data, but what else do they bring to the table whenever I want to share information with somebody else? So let's say I share this project with someone else, and I want them to be able to utilize the same exact data that I have inside of my database. Well, currently I have my Poke API database. I'm going to go ahead and exit the Poke API DB. And this is only for demonstrational purposes. Please, you can completely data dump everything that I'm about to talk about from this moment on forward. So just keep that in the back of your mind. If at any point it gets confusing, just disconnect. All right, so here I'm going to go ahead and delete, or excuse me, I'm going to drop DB, my Poke API DB. That's going to then delete it. In this separate terminal, if I try to enter, you'll see I get, hey, this database does not exist. Okay, now I'm going to recreate it. And when I execute that same command, well, now I can enter, but all of my relationships are now gone. So I can migrate. All right, everything has been migrated, including Pokemon app 001 and 002. I can run select all from Pokemon app, but there's no entries. Pikachu doesn't exist. Well, I want to share my data with other developers. I want other developers to have the same data structures that I'm working with. So I also share this fixture. And now I can run Python, manage PY, load data from Pokemon app, fixtures, Pokemon data 002.json. You can see here it says it installed one object from one fixture. And now when I run that same query, we're back to having our Pokemon of Pikachu. So this way, another developer who's new to the project can grab my data fixtures, install them into their own database, and we would both be working with the same data structures, or excuse me, with the same data entries. Does anyone have any questions over fixtures or how to apply different model field types into our model? Go ahead, Arnold.
So just to recap, so load data, and then you can just copy paste the file path of Pokemon data 002.json.
That's correct. Yes. All right, Tom.
When we create these migrations, is that stored on the fixtures? Like if we wanted to give this to another developer, like where does some of this live? I know some of it lives on fixtures, but like where would like the um I guess I'm just getting confused as to where certain things would live and other things not, like what might disappear.
Interesting. Okay, so when it comes to sharing information with other developers, nothing itself is going to disappear. So the migration files are being kept track of inside of the migrations directory. And every time you push up to GitHub, all of these will be pushed up along with it. Now, the actual data within your database, that's inside of your own machine. So that's not actually going to get pushed up into GitHub, right? So to get around that, we create fixtures. And this way, our fixtures can push a representation of the data that's inside of our database, and other developers can install it into their own database machine. Does that answer your question, Tom?
Yeah, that clarified it.
Awesome. Any other questions? Let's hear it, Chris.
Yeah, so just to recap on that process, it was um, if they if they're creating a DB, they could just get the name from the settings file, or they could just rename it with whatever DB they named it, right? And then do the Python manage.py migrate, and then the load data.
Right. Yes. So they would
Okay.
migrate first and then afterwards load data. All right. Awesome. Well, now let's move on into taking a look at our model here in a deeper sense. We were able to add a couple of fields, which is fantastic. But now when I want to take a look at my model, if I come over to the shell, so let's say Python -py shell, and I try to make a representation of Pikachu, and I say, hey, this is Pokemon dot objects dot first. Yep, that's what I meant. I meant objects, excuse me. And then I print Pikachu. Well, I get Pokemon object of 1. Now, this doesn't really give me much of a description as to what it is that I'm working with. So I want to change some of this information so that I have a better representation of this class instance. Does anyone remember what method would allow me to create a representation of the class instance? Something that was readable rather than telling me a memory space? All right, it's going to be the
Be
dunder
like,
string method. All right. So we're going to come over to our models. And inside our models, we're going to simply just say, hey, This is still OOP, so we should be able to utilize a dunder string method where we take in self and just return an F string, where I can say, hey, the Pikachu or Pokemon of self.name is at level self.level. And let's do is if self.captured, else is not captured. Okay, so now this runs. I'm going to go ahead and exit this because any updates that I have made need to be changed or updated into the shell. Again, I can call Pikachu and make that equal to Pokemon.objects.first. And now when I go to print Pikachu, you can see that my dunder string method is represented. Right? Pokemon Pikachu is at level 22 and is not captured. This is a much better representation of my model. I could change this so that it shows me the entire values inside of the default string, but this is more than enough that I need for now. I could have other methods. I could even have getters and setters if I wanted to. In this case, I could have something like, hey, I want to be able to level up. And I can say, hey, self.level is equal or plus equals 1. And I can write that information right there and there. Right? I can save that information to make sure that my database is updated. Well, let's make sure that this works. If I try to run Pikachu dot level up, this would create an error. It would tell me, hey, there's no such attribute or method named level up. That's just because my shell isn't tracking that I've made that change. Again, I can bring in Pikachu be equal to Pokemon. You can see why I created the playground. This is becoming a little repetitive. Dot objects dot first. All right, and then now if I print Pikachu dot level, I'll get 22. If I run Pikachu, and let me actually demonstrate that here as well. We can see that 22 is being provided to us for the level. Now I can run Pikachu dot level up. And if I execute print level, well, now I have 23 being represented down below. And if I take a look at my database, it also shows 23. And this dot save is what writes to the data table. All right. Any questions regarding these methods? Awesome. There's one more method we're going to add. This is just going to be change got status, which is going to take in self. And it's going to say self.captured is equal to not self.captured. Okay, from there we can self.save. And that will create the entry for us. All right, awesome. Again, this is still OOP. There's even a way that you can utilize inheritance between your Pokemon models. You just have to make sure that you create a class meta. We're not going to cover that here in Code Platoon, but know that that is a possibility in case you have an application where you want to formalize inheritance. Now, there's one more thing that I want to cover here, and this is going to be a pretty dynamic way to interact with our model called the Django admin site. Now, Django is going to provide a server for us. This server can be viewed by running Python manage py run server. Now, before, when we utilize Flask, all we had to do was execute the app script. And in the app script, at the very bottom, we had a run server command. Now in Django, you quite literally have to tell manage.py that the action you want to take is to run the server. When I press enter, that's going to run the server. This is telling me, hey, this is only for production, or excuse me, this is only for development. Don't use this for production. And it tells me the address that my server is going to be working at. So now I can open up my server, and here you can see that I get a, hey, welcome to Django. Your application's up and running successfully. Awesome. Well, I want to actually enter something that will allow me to interact with my users, or excuse me, that interact with my models. So I can simply just go into admin. We'll talk about these URL patterns and how I know that admin exists in a future lesson. Now, when I go to the admin site, you can see that the request is being processed. It sends a GET request, all of these static representations. This template and this site comes batteries included. It has already been built for us in Django. So this is just basically giving Google Chrome all of the static files, which is HTML, CSS, and JavaScript, to be able to render this application. And you can see that it's asking for username and password. But as of right now, I have no user with no passwords that can actually enter this. I've never created one. So let's fix that. I can enter here by running Python manage.py create super user. Here I can specify a username. I'm just going to use FR. An email address would be fr@fr.com. Here's a password. Here's another password. I'm going to violate the restrictions, so I'm going to run yes. All right, now if I refresh my site is broken. That's currently because I'm not running my server. So let me go ahead and run my server again. I can refresh my site one more time. Great. And now I have a user that can actually enter the name that I mentioned, along with the password that I've created. And when I click on login, I get access to the Django administration site. Now, this Django administration site, what does it actually give me? Let's see, I have this users directory, which has the user that I just created. Okay, great. If I go back to home, it shows me a couple of groups. I don't have any user groups, and there's no actions available. Well, this doesn't really give me much to work with as of now. So what's the point of this entire site? Well, you'll notice that inside of your Pokemon app, there's a file named admin. And this admin file ties directly to the admin site. Here, I can say from .models, I want to import Pokemon. And then I can register that model. I can say admin.site.register and pass in Pokemon. You'll notice that every time I was making a change to this file, my server was reloading. Just like React, the Django server has a hot reload function. So every time you make a change to a file, it's going to automatically update and change the information that's available. Well, now when I refresh my static site over here for admin, you can see the Pokemons are now included from the Pokemon app. If I click on Pokemons, I have Pikachu that's available to me. And this is the exact copy and paste from my dunder method. If I remove my dunder method, my static site loses the representation of Pikachu. So my dunder method or my representation method is what gets rendered by my static site. If I click on Pikachu, here I have the availability to edit my information, right? So here's Pikachu, the level that I currently have it at. I can change it all the way to 20. I can update the date, make sure that it is captured or not. change its description saying, hey, Pikachu is a lightning. Is it lightning or thunder? Wow, electric. There you go. That is embarrassing. Is an electric type Pokemon, and it will evolve with a Thunderstone into Raichu. All right. And then I can save this information. And let's take a look at what happens between SQL now. Well, now when I run it, you can see that the data has been updated. All right, Pikachu is now level 20, which is what I dictated there. I also changed its captured variable from false to true, and I updated the description. Now it says Pikachu is an electric type Pokemon, and it will evolve with a Thunderstone into Raichu. All right, so I'm able to do all of my actions instead of utilizing the Python shell here on the admin site to interact with my models, which is super nice and friendly. I can even create new Pokemon. I can click, hey, I want to add a Pokemon here. I want to add Charizard. I want Charizard to be, I don't think Charizard evolves until like level 36, but I may be wrong. All right. I can change the date captured to be today. The captured Pokemon as well to be today, time, which is as of now. And the description could be Charizard is a fire type Pokemon, and it is the third evolution of Charmander. It is also not a dragon type. Make sure that it's captured and save it. And I also have Charizard included in my database. So if I come back over, run my select query, well, now Charizard is included in my database. So instead of utilizing the Python shell and making my life more complicated than it needs to be, I can just utilize the admin site to interact with all of my models. All right, and I see a hand up. Go ahead, Tom.
Couple things. I'll just start with where you're at now. I noticed that it said that you were 8 hours behind your server time. Is there a way to set your designated server time? Because I know that with tokens and stuff, that can get funny if there's too much of a time mismatch.
Yeah, that's a great question. You can absolutely do that. It's going to be here inside of your settings.py. So in your settings.py, let me see here. I believe template WSGI database. Here you go. Time zone UTC. You just have to change that to the specific time zone that you want to be reflected. The time zone codes are inside of the Django documentation. So you can look at the Django documentation, find your desired time zone code, and just paste it right in there.
Excellent. The other question I had was under your admin.py. Okay. That's all I needed.
Oh, perfect. All right. Go ahead, Rick.
Uh, well, a comment. Most all servers, I think worldwide, are all set to UTC. So if you're making API calls to other servers, some servers will not return a response if your time's too far off. But my other question, or that was a statement. My question is this, and I'm sure we'll get to it, but this admin page is really nice and cool, and it's got a lot of functionality. But are we able to pass that API to? I'm sure we can, to like a React application, so your front end can log in to your administration site.
Yes, so eventually we're going to go through that process of actually giving the entire CRUD capabilities to our
Uh,
API, but we're not there yet.
yeah, that's cool. All right.
Awesome. All right, any other questions? Okay, awesome. If there aren't any other questions, let me do a quick recap of what we covered during part two of our lecture. In part two of our lecture, we talked about all the different model fields available. I shared this documentation as to where you can find the different model fields, along with some pretty clear descriptions and even the source code of um, what each field type is available. We then moved into generating fixtures and why we're generating fixtures. Again, we generated our initial fixture by dumping our data from Pokemon app into this fixture directory. After updating our model, we created a secondary fixture holding all of our information. And now that I'm about to end the day, I should probably generate another fixture stating, hey, Python manage py dump data Pokemon app dot Pokemon dash dash indent 2. I want to dump this into Pokemon app pictures. I'm going to say Pokemon data, and I'm going to add the date today, which the date would be 2025. At 11:20.json to highlight that this is the end state of today. All right. From there, we moved into, hey, models are still just classes in OOP. And we created a couple of model methods for our class, starting with our dunder string method, creating a level up method, and creating a change caught status method. And then we dove into the Django admin site. First, by registering our model, creating a super user through the command line, utilizing the create super user command, running our server, coming over to the admin site, and then interacting with each one of with the one model that we have created, either by updating values or by creating a new Pokemon. Notice that you can also delete a Pokemon there, which we didn't cover. At this point, I could log out and try to log in again. All right, does anyone have any questions regarding part two of our lecture? Let's hear it, Chris.
Yeah, it was just something that came to mind. I think, do all classes create tables, database tables, or is it just specified by the models.model?
Yeah, only the models.model, any class that inherits from models.model will actually create a database table, unless specifically told that it's supposed to be a template.
Okay, thank you.
Of course. Any other questions? All right, that's going to conclude part two of our lecture today. Let me go ahead and stop the recording.